Hi everyone, welcome back to Math 251. In today's lesson we are talking all about something called a limit. And this first definition here is straight from the textbook. It's a little bit long and complicated, so I wanted to go through it and see what it's saying piece by piece. So let's read it together and then we'll go through it a little bit at a time. It says, let f of x be a function defined at all values in an open interval containing a with the possible exception of a itself, and let L be a real number. If all values of the function f of x approach the real number L, as the values of x, possibly not equal to a, approach the number a, then we say that the limit of f of x as x approaches a is L. More succinct, as x gets closer to a, f of x gets closer and stays close to L. Symbolically, we can represent this idea as the limit as x approaches a of f of x is equal to L. So what is all of this saying? Let's go through it a little chunk at a time. It first says, let f of x be a function defined at all values in an open interval containing a, with the possible exception of a itself. So basically, if the function that we are looking at here is f of x, this piece is saying that we have to be defined on some interval that we are concerned with, maybe some interval like this, except it's okay if we have a hole at the point A. We just have to be defined everywhere else. The next little chunk here says that L is a real number. Well, that just means exactly what it sounds like. L is a number here. The important thing to remember when we are looking at this number L is that L is always going to be the y value on the graph that we are concerned with. Next, it says that if all values of f of x approach the real number L, as the values of x approach the number a, then we have this limit that we're talking about. So let's draw a little bit on this graph here. It says if all values of the function f of x approach the real number L, as the values of x approach the number a, so we are getting really close in the x direction to this number a from both sides. That's what's happening here. So that is our chunk here as the values of x approach the number a. And we want the y values to get really close to our number L. So what's happening in the y direction here? Well, if we follow our graph, as x gets really close to a from this direction, we can see that on the graph, yeah, we are approaching this number L. And as we approach a from the other side of the graph, we are also getting really close to that y value of L. So this is what it looks like on a graph. And if this is true, if all of the y values approach this number L, as all of the x values get really close to this value a, then we can write this limit. We read this as the limit as x approaches a of f of x is equal to L. So this is kind of a visual representation of what a limit actually is. So now let's do a few examples. Here we have this graph. It is a quadratic graph, and we want to know what the limit as x approaches 6 of f of x is. Well, first of all, we know that this limit is going to be a y value, and we want to know what the y value of this function is as the x value gets really close to 6. So if I were to go on my x-axis here, I'm getting really close to this value of 6 from both sides. So I'm approaching 6, and then what happens on my graph? Well, if I approach x equals 6 from this side of the graph, I see that I'm getting really close to that y value of 2. And if I approach x equals 6 from this side of the graph, I also see that I get this y value of 2. So that means that the limit as x approaches 6 of our function f of x is equal to 2, where this 2 is the y value that corresponds to that ordered pair as x approaches 6. What about a table? What if we were given this table instead and asked to find the limit as x approaches 3 of f of x? So here we don't have a visual representation, but we can still figure it out. Again, we want the y value here. And we can see that in this table, all of our x values on both sides, a little bit less than and a little bit greater than the value that we care about, are all approaching the number 3. So here, all of our x values are getting really, really, really close to 3. And what's happening to our y values? Well, on this side, they are slightly less than the number 6. And on this side, they are slightly greater than the number 6. Regardless, from both sides of x equals 3, our y value is approaching 6. So that is our answer here. We have the limit as x approaches 3 of f of x is equal to 6. Now, it's worth noting that if we look at this graph, at x equals 3, our function is undefined. That is okay. All this means is that there is a hole at x equals 3. And if we think back to that definition that we read at the beginning of this video, it says that we just need f to be defined on some interval, and it's okay if that interval does not include that point a. So here we just have that hole at x equals 3, which means that it's undefined, and that does not affect the fact that we still have this limit that is valid. So that's pretty important to keep in mind. That's it for this video. We have a couple more for today, so go ahead and watch those. Bye.